There are these animals that came from off-world. These are outcasts. NASA, famous for its significant revelations, has actually revealed that this new planet isn't just entrancing in light of the fact that of its size and region, but also because it shows lights that have all the reserves of being fake. Are we practically uncovering insider realities that could change our perception of the universe? Might this disclosure at some point mean there is life on different planets? Come with us as we examine NASA's charming revelations and uncover the truth about these amazing lights. In 2007, NASA shipped off the Dawn spacecraft with a mission to explore the most entrancing objects in our nearby planetary group. Dawn was extraordinarily equipped with 3 ion engines, allowing it to undertake an exceptional journey. Dawn's trip began with a 14-month investigation of Vesta, the second-largest space rock in the belt. During this time, Dawn sent back detailed pictures and data, revealing Vesta's perplexing surface and various land histories. After completing its primary objective at Vesta, Dawn set out on the second, and perhaps most charming, part of its endeavor, a close-up examination of the dwarf planet Ceres. Because of its ion engines, Dawn was able to leave Vesta's orbit and set off to reach Ceres, an achievement that traditional chemical propulsion would have found challenging. These engines, given a persistent gentle push, enabled Dawn to travel vast distances efficiently and enter a stable orbit around Ceres. First discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the space rock belt between Mars and Jupiter. For a long time, it was considered the smallest dwarf planet in our solar system until its renaming in 2006. With a diameter of around 950 kilometers, Ceres is the largest and most massive body in the space rock belt, and one of the most interesting due to its unique characteristics. As Dawn advanced towards Ceres, scientists eagerly anticipated the first detailed pictures of this abnormal world. They saw bright spots scattered across its surface, most notably in a large crater, now known as a Cater crater. These bright spots sparked immediate interest and hypotheses among mainstream scientists. Before Dawn's mission, the best image we had of Ceres was a blurry, low-resolution photograph taken by the Hubble Space Telescope. Experts knew very little about this dwarf planet, and the possibility of finally getting a close-up view was exhilarating. What secrets would Ceres reveal? What new discoveries awaited the mission? Dawn promised to enhance our understanding of the nearby planetary group's development and the role of water in shaping planetary bodies. The bright spots on Ceres were unlike anything seen on other asteroids. They seemed to be made of highly reflective material, possibly salts left behind by sublimated water. This led to the possibility of cryovolcanism on Ceres, a process where volcanoes erupt with water or briny liquids instead of molten rock. But what exactly are these mysterious lights, and what do they reveal about Ceres? Might they be evidence of ongoing geological activity, or something even more extraordinary? Ceres stands apart from other celestial bodies in the space rock belt due to its size, mass, unique composition, and potential for water and ice. Unlike most rocky asteroids, Ceres has a composition more akin to a comet, suggesting it holds more secrets about the early solar system than we ever imagined. After 2 years on its journey, the Dawn spacecraft finally began its approach to Ceres in mid-2015. This moment marked a major achievement in the mission, as Dawn was able to deliver humanity's first close-up views of the largest object in the space rock belt. As Dawn drew closer, the pictures of Ceres grew increasingly detailed, offering glimpses of a world previously shrouded in mystery. The first images revealed a surface dotted with craters, characteristic of a long history of impacts. However, it wasn't just the craters that caught the attention of scientists and space enthusiasts alike. Among these features were strange bright spots that distinctly contrasted with the darker, rough landscape. As the pictures continued to improve in resolution, mainstream scientists buzzed with hypotheses about the nature of these bright spots. Were they ice patches reflecting sunlight, or could they be something much more colorful? Speculations ranged from mineral deposits to possible signs of cryovolcanic activity. Incredibly, closer analysis revealed that the brightest spot was not a singular substance, but rather a collection of several distinct spots. This discovery only deepened the mystery, The hypothesis that these were deposits of salts left behind by sublimating water gained traction. This would suggest that Ceres had, or still has, some form of geological activity capable of transporting water or briny liquids to the surface, where they rapidly evaporate, leaving behind brilliant, reflective deposits. These revelations challenged existing ideas about Ceres, showing it to be a more complex and dynamic world than previously thought. The presence of such features raised the possibility of subsurface water or briny pockets, which could have significant implications for our understanding of the potential for life in our solar system. But what makes Ceres remarkable compared to other planets? Ceres is an intriguing world, often described as a cold planet with a rough yet permeable surface. Unlike most asteroids in the belt, which are composed mainly of rock and metals, Ceres stands out due to its notable composition. Its surface is a mixture of water ice and hydrated minerals, including clays and carbonates, which give it a significantly less dense structure compared to its neighbors. This composition suggests that Ceres has a large amount of water. The surface layer is rough but permeable, with ice and other volatiles trapped inside. This frosty characteristic is more reminiscent of a comet than a typical asteroid, indicating a history that may have involved a combination of rocky and icy materials. Digging deeper beneath its surface, Ceres reveals even more fascinating aspects of its structure. The dwarf planet is believed to have a differentiated interior consisting of a slushy mantle and a core. The mantle is thought to be rich in water ice, making up about 50% of Ceres' total volume. This mantle, possibly a mix of rock and salty water, surrounds a core that may be composed of denser material, possibly silicates. The presence of such a large amount of water ice suggests that Ceres may have once held liquid water, particularly if its core was heated by radioactive decay early in its history. This internal structure sets Ceres apart from its asteroid neighbors and also raises intriguing questions about its potential for geological activity and the role of water in its evolution. But that's not all. The discovery of ammonia clays on Ceres suggests that the dwarf planet may have formed in a colder part of the solar system before migrating inward. The presence of ammonia lowers the freezing point of water, supporting the idea of subsurface brines. These insights into Ceres' structure and history not only enhance our understanding of this captivating dwarf planet, but also offer important clues about the processes that govern the formation and evolution of icy bodies throughout the solar system. Cryovolcanism is a fascinating and relatively rare geological process, especially when compared to the more familiar volcanic activity we see on Earth. Unlike conventional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, erupt volatiles such as water, ammonia, or methane. These substances can exist as liquids or gases in the supercold environments where cryovolcanoes are found. On Ceres, cryovolcanoes function by allowing water mixed with dissolved salts to reach the surface. When this briny water interacts with the vacuum of space, it quickly sublimates, changing directly from a solid or liquid state to gas, leaving behind bright, reflective salt deposits. These salt deposits form the mysterious bright spots seen on Ceres' surface. The most famous of these bright spots is located in a crater named Decatur, known as Spot 5. This region has attracted significant attention due to its high reflectivity and intermittent fogs observed by the Dawn spacecraft. These fogs are believed to be caused by the sublimation of water, suggesting that cryovolcanic activity may still be ongoing or may have occurred relatively recently. Moreover, Ceres has several other bright spots, each with its own unique features. These spots are not limited to one region but are scattered across the dwarf planet's surface, indicating that cryovolcanism might be a widespread phenomenon on Ceres. The presence of these bright spots underscores the exceptional nature of Ceres and raises important questions about the potential for life in our solar system. The dynamic and evolving nature of Ceres challenges previous assumptions that it was a geologically dead world. As the Dawn spacecraft provided more detailed images of Ceres, a wealth of surface features began to emerge. The surface of Ceres is dotted with various craters, each telling a story of the dwarf planet's history. Some craters are relatively shallow and eroded, indicating an ancient surface that has been subjected to numerous impacts over billions of years. Others are better preserved, with sharp rims and deep bowls, suggesting more recent impacts. Interestingly, the number of craters on Ceres is fewer than initially expected. This discrepancy points to geological processes that may be resurfacing the planet and erasing evidence of older impacts. One hypothesis is that Ceres' icy crust allows for a form of cryovolcanic resurfacing, where subsurface materials periodically well up and cover older features. This ongoing geological activity suggests that Ceres is not a static world, but one that has been, and may still be, actively evolving. Additional evidence of surface deformation on Ceres comes from the observation of fractures, grooves, and ridges on its surface. These features show that Ceres' crust has experienced significant pressure and stretching. Some of the cracks appear relatively young, possibly only a few hundred million years old, suggesting that the crust is still somewhat active. The ridges and grooves on Ceres likely formed as the crust was stretched and pulled apart, while lines of mountains and compressional ridges indicate areas where the surface was pushed together. These contrasting features provide a glimpse into the complex processes that have shaped Ceres over time. The presence of a large dome-shaped mountain in one of the craters suggests the possibility of internal pressure or upwelling of materials, possibly linked to cryovolcanism. This feature, along with the extensive network of cracks and ridges, points to a dynamic and evolving surface. Dawn's mission has also revealed fascinating surface formations beyond the bright spots and reflective salts. NASA's data has uncovered a range of surface materials that are key to understanding Ceres' geological history. For instance, specific areas on Ceres display a dark, fine-grained material that stands out in stark contrast to the brighter salt deposits. This darker material is believed to be a type of carbon-rich substance, possibly organic, adding another layer of complexity to Ceres' composition and suggesting a potential for prebiotic chemistry. The relationship between these materials and the icy surface could play a role in the chemical processes occurring on Ceres. Moreover, the discovery of organic compounds on Ceres has sparked significant interest in astrobiology. Organic molecules, which are the building blocks of life as we know it, have been found in carbon-rich mixtures. These findings are particularly exciting because they suggest that Ceres may have conditions suitable for the formation of more complex organic molecules. The presence of these compounds opens up possibilities for life, or at least the building blocks for life, being present on this dwarf planet. Another remarkable feature is the large number of mysterious dome-shaped structures on Ceres. These domes, some reaching heights of up to 6 kilometers, are believed to be the result of subsurface processes pushing material through the crust. Their shapes and sizes suggest that they could have formed from cryovolcanic activity or internal pressure forcing materials upwards. Understanding these formations is crucial for unraveling Ceres' geological history and its interior structure. Additionally, the gravity data gathered by Dawn has provided insights into the internal density distribution of Ceres. Variations in gravity reveal the presence of different layers within the dwarf planet, indicating that Ceres' interior may have complex structures, including a potential subsurface ocean or briny pockets. These discoveries are crucial for understanding Ceres' thermal history and its potential to support conditions favorable for life. Overall, the Dawn mission has not only expanded our knowledge of Ceres, but also transformed our understanding of small celestial bodies in the solar system. As more data is analyzed, scientists hope to unravel the mysteries of this captivating world and its potential to provide insights into the broader processes that govern planetary evolution and development.